the total mechanical energy of a system. Now remember that the mechanical energy of a system is equal to the kinetic energy plus the potential energy. Right? It says the total mechanical energy of a system can never be negative. I don't know. Is constant only if non-conservative forces act. Is constant only if conservative forces act. Is equally divided between kinetic energy and potential energy. Is neither all kinetic or all potential at any one point in time. Okay, so some of these aren't true. All right.
Wait, what are conservative and non-conservative forces?
A non-conservative force is like friction. So so conservation of energy. Like remember our lab. We applied the principle of conservation of energy, but we lost some energy due to friction, right? So the friction has a change in the acceleration, which alters the velocity. Also, there's sound that's made. You can't hear it, but there's mechanical vibrations. All that stuff weighs into the effect of the energy. But there are forces that are conservative. For example, gravity. A force that's created by the acceleration due to gravity is a conservative force because that's where the potential energy comes from. Okay, so it's just kind of a label.
So conservative is like non-conservative pushes against something. Like
Yeah. So if we were to do that lab with no friction, it would equal the initial mechanical energy would always equal the final kinetic or the final mechanical energy. So if I was in space and I had a potential energy and a kinetic energy, and then I changed that some way somehow, my final energy, mechanical energy, would be the same as my initial because there aren't any non-conservative forces. Does that make sense? So I think it's C. Yeah. So as long as there's only conservative forces that are at play, then it's constant. In other words, it never changes. Now the kinetic energy and the potential energy can transfer. Those can vary all day long, but the sum of them will always be the same. So what they're really saying by this is like, okay, let's say I have 10 joules of mechanical energy. Well, there might be a point in time where I have 7 joules of kinetic plus 3 joules, but then later on in time, for whatever reason, I might have 3 joules of kinetic plus 7. This is like how a roller coaster works. So if we were to make a roller coaster that didn't experience friction, this is the sort of thing that you would see. But notice that the mechanical energy will remain constant. That's what option number C is talking about. Does that help you guys? Does that make sense? But now, as soon as we introduce friction, this changes. This would be like 7 joules. And it'd be like 4 joules plus 3 or whatever, whatever. And we would lose 3 joules to non-conservative forces. So it can never be constant, ever, if there are non-conservative forces like friction, okay? Mechanical waves like sound, stuff like that.